All right, this is a lesson on reflections. So let's take a look at that first blank. It says, along with translations, reflections are also and. The word you want to put in here is an isometry. An isometry. I-S-O-M-E-T-R-Y. And what I just want to do is, over here, let's take a look at the word. The prefix ISO, and if you just Google, and I did this yesterday, I won't do it right now because we've got the recording. I just Googled define prefix ISO, and basically it just means equal. So anytime you see that prefix ISO, that just means that something's equal. And the suffix metry, like in geometry, okay, it basically means the measure. So an isometry is when you have two things that have equal measures. Okay? So an isometry would be two objects that have equal measures, that are congruent. That have equal measures. So an isometry is also known as what we call, or a transformation that gives us an isometry is also called a rigid transformation. Rigid implies stiff, unchanging. So it means that the pre-image and the image are going to be congruent. All right. Next, reflections require a flip. Okay. Something gets flipped over a line. Now let me ask you something. You stand in front of the mirror this morning. Hopefully most of you, if not all of you did. You're doing your hair, you're brushing your teeth, you're popping a zit. Whatever you're doing in front of the mirror at 6:30, 7. Some of you are in front of the mirror at 7:20. Still being ready to be on time for school. When you're there, if you're standing 6 inches in front of the mirror, how far is your reflection away from the mirror? 6 inches, right? So in other words, if you and your brother or you and your sister are standing in front of the mirror arguing, elbowing each other out of the way, you're 3 inches because you're doing something, whatever. The other person's 1.5 feet. Then the reflections are also 3 inches and 1.5 feet away. So when you're doing reflections, you start off with a mirror line, like this line right here. And however far a point is away from it, the reflection is going to be the same distance on the other side of that line. So look at this. Look how far away C is from that line. Put C prime about the same distance on the other side. Look at how far A is away from the line. And put A prime about the same distance away on the other side. And then look how far B is away. And put B prime about the same distance. When you're done, connect the dots to form your triangle. Here's the thing, man. Do the best you can. A lot of the reflections we're going to do are going to be in a coordinate plane, so you're going to be able to count the grid lines. So it's going to make it a little bit easier to be more precise. All right. Don't worry about this blank right here. We're not going to worry about filling that in. All right. A reflection involves if you will, a flip of an image, usually over the X or Y axis. It may also be flipped over other lines, such as y equals x, x equals 2, or a bunch of others. The best way to graph the image of a reflection is to simply graph the pre-image, measure the distance from the line, and then find the image the same distance on the other side of the line. What I want to do now is walk you through 6 commonly used lines that we're going to use. Okay? We're going to use the x-axis. We're going to use the y-axis. We're going to use any kind of horizontal line or any kind of vertical line. And then we're going to use the line y equals x and y equals negative x, which I'll talk about in just a minute. Okay? Once we get through those 6 lines, I'm going to go ahead and I'll pause this video. I just hate creating like this 35, 40-minute long video. I'd rather do it in chunks. So once we get to that point, we'll stop because that's the content. After this is all just examples. All right? So we'll pause it after this one. I'll give you guys like 2 or 3 minutes to just take a break, and then we'll get started. And for the sake of people watching this now as well as later, let's go ahead and do this in colors. So I'm going to do the x-axis in red. I will do the y-axis in orange, and I know it looks kind of similar, but I'm going to make it big enough that it won't look all that similar when we do it. Green is going to be the line y equals 2. Blue will be the line x equals negative 3. I'm going to go dark purple is going to be the line y equals x. And then we'll use a light purple to do y equals negative x. Everybody clear where the x-axis is? Good. So whatever you need to do, that's your x-axis. All right. Nice and easy. Y-axis, again, one of those things I hope everybody is aware of, is the y-axis. I don't want dotted anymore. We'll make it solid lines. All right. So let's take a look at the line y equals 2. The way to think about these, because, again, listen, some of you are going to memorize this and you're just going to be able to do it. Others of you, the way your brain works is you analyze it. If I can figure something out, then I don't have to bother memorizing anything. I can just figure it out. For example, when I graph y equals 2, to this day, 20 plus years later, I still have my preferred way to think about it rather than all these other methods, okay? So here's the deal. Some of you are just going to know and remember that this is just a horizontal line. Way back in algebra and algebra 2 in high school, I always screwed up which one was horizontal, which one was vertical. It wasn't until it was explained the way that I'm about to explain it, which is still 30 plus years later, still the way that I do it. Ready? Here it is. A graph or a line or an image of an equation is just a collection of points. Okay? All of these points have a y-coordinate equal to 2. So watch this. Ready? That means the point 0, 2 is on that graph. That means the point 1, 2 is on the graph. That means the point 5, 2 is on the graph. That means the point negative 3, 2 is on the graph. And if you plot all the points that have a y coordinate equal to 2, we get that line right there. All right? X equals 3, for the same reason, is a vertical line. So here now are all the points that have x coordinates of -3. So let's plot some. X, oops, we've got to get the right color. So -3, 0, -3, 2, -3, -1, -3, -5. And if we connect all those dots, we get that line right there. I'm going to go ahead and make those a little bolder. Just to make sure that everybody can see them clearly. All right. The last two are the hardest. And more than anything, I think this is where some of you are just going to have to just memorize that y equals x looks like this, y equals -x looks like this. But again, if you want, we can still use that same principle. All righty? Watch this. Let's look at points whose y coordinate is the same as the x coordinate. Ready? That means 0, 0, because x and y are the same. 2, 2, because the x and y are the same. 5, 5, because the x and y are the same. -1, -1, -3, -3, so on and so on and so on. And what you get when you connect all those dots is a line that looks like that. Give me just a minute and I can come back and take a look. So if you want, here's a nice easy way. It's a, let's see here, through the origin at a 45-degree angle, right? 45-degree angle would be half of 90. So if you just come up through the origin at a 45-degree angle, that's the line y equals x. And then y equals -x. So these are the ones whose points have y coordinates that are the opposite of the x coordinates. So watch this. If I have an x coordinate of +1, then that means the y coordinate must be -1. If I have an x coordinate of +2, that means the y coordinate's got to be -2. If the x coordinate is -3, then that means the y coordinate is +3. And if you do that a few more times, we get a line that looks like this. All right. So we'll go ahead, we'll continue this in the next recording.